Hello and welcome to another video lab. Thank you so much for being my partner today. I'm just going to get started and just acknowledge right away that for most of the lab, my head is going to be cut off and you're going to mostly just see my hands. That's because I'd rather have you see the lab setup than me. All right. So again, thanks for being my partner. Welcome to our types of reactions video lab. The whole focus for this lab, if you look at the EQ, is to see a bunch of different lab chemical reactions and then be able to write the balanced equation, classify those reactions, take some data. There's a whole bunch of little pieces that you'll be putting together by doing this lab experiment. So let's go ahead and get started. So you should already have downloaded or printed your lab handout so that you have the steps that I'm going to be doing, and then you can be writing down the observations for sure. You could do the balanced equations and the classifying, the reaction type, after the video if you wanted to, or you could do the observations, pause the video, finish the equations and all of that, and then you could pause or play the video and go on to the next one. That part is up to you. But for sure, you want to have something to write down so you see what I'm doing and then also have a place to record your observations. So the first one says that I need a wad of copper, about 3 centimeters across. So here's my wad of copper, and I need to put it in a clay triangle. In a crucible that will eventually go on top of a clay triangle. And then you can see my setup here. I've got a ring stand and a ring that I will put on it. So this will be my ring on a ring stand. That's where that term comes from. All right, so get that clamped on there. And then that clay triangle will set on that ring. And then I have a Bunsen burner. And that Bunsen burner, I want to heat my sample really strongly. So notice how close I have that. And that's on purpose. And then I'm going to plug in the hose to the spout that has our gas. So make sure that's secure on there. Move some of that other stuff out of the side. And then we'll use a lighter to light that Bunsen burner. Oh, first though, I should finish getting things set up. So then I put that crucible, which is this little, it's made out of porcelain cup, in that clay triangle that's on the ring stand with the Bunsen burner. And notice that I've got it pretty close together, which again was on purpose. And then it says that I would like to heat it strongly for 5 minutes. So I turn on my gas, you can hear it. And then I'm gonna heat that as strongly as I can. You can even hear it, right? It sounds like a little engine. And I'm going to heat that for, I don't have a watch here, but I have it on my computer. I'm going to heat for 5 minutes. All right, so I'll come back and check in with you in 5 minutes. Okay, so that has been approximately 5 minutes. So I'm going to go ahead and turn off the flame. So you'll hear that noise stop. And then take a look at observations. So take a look at what it looks like now. So maybe you remember it started as like a reddish brown color because it was copper. And now you'll see that it's pretty dark gray. It's got little pieces of, pretty much gray. I don't really see anything else. So kind of gray coated now. And I'm going to take that. And so the reason this happened is because there was a chemical reaction between copper that turned into the copper plus 2 ion reacting with oxygen in the air. And it says in this next step, so I'm at 1B, I'm going to take that wad of copper and put it in a 50 milliliter beaker. And then it says that I'm going to add 5 milliliters of something called 3M. That 3M is the concentration of the sulfuric acid. And the sulfuric acid 3M means there's 3 moles. We're going to learn about moles in our next unit, but basically it's some amount of the particles of sulfuric acid mixed into water to create a solution. And I'm going to measure some of that. It says about 5 milliliters. And then I'm going to mix that with the copper wool. All right, so I'm going to use a graduated cylinder for measuring. And then notice some safety things that are going on. I have my acid in a secondary container. If I were to spill the acid, I would neutralize it with baking soda first. And then I'm going to use this pipette to kind of help me measure this. So I'm going to place my graduated cylinder in there. And then I'm just going to add, it says about 5 milliliters. I happen to know from this lab experience that I'm going to do a little bit more than 5. So maybe I should adjust those directions for future. But I'm going to just, it doesn't have to be an exact measurement because I'm not going to use that number for a calculation anywhere. So it can be kind of approximate. So I've got my sulfuric acid, and I'm going to put that into my beaker with my copper. So I pour that together. And then it says that I need to stir it. So I've got a stir bar stir rod. And then notice as I stir, notice that you can kind of see some of that copper color start to appear again. So I try to stir that up really well. So I'm trying to get all the stuff that was on the outside of the copper to mix into the acid. So see now how it looks kind of back to that sort of copperish color? That's because all the stuff that was on the outside of the copper, that new compound, I'm kind of mixing off and putting into that acid instead. All right, so I'm gonna let that sit for a little bit, and then I'm gonna go on to do what it says next. So I'm gonna set up a filter funnel and a filter, and so that I can filter it. So I'm taking a piece of filter paper, and to set up a proper funnel, what you do is you fold it in half. So now it's a semicircle, and then fold it in half again. So it kind of is like a cone. And then see how there's 4 layers here? 1, 2, 3, 4. So I'm gonna separate it so there's 1 layer on one side and 3 on the other. And then that creates a cone that's continuous. And I'm gonna put that inside my funnel. And then I need to wet it down so that the liquid from my beaker doesn't just soak into the paper. So I'm going to use DI water so that I don't have any contaminations from the tap water. And I'm just holding this over the sink and just wetting down that paper just a little bit. Okay, so now I have my dampened filter paper. I'm going to put that in an Erlenmeyer flask. I like the shape of this for a filter because then what happens is it fits in there, the funnel fits in there really nicely. You're not going to get any splashing. And so that's my filter setup ready to go. All right, and then I'm going to take my beaker that has the acid mixture and the copper mixture, and then I'm going to just put that into my funnel. Kind of scrape out any of those things that are left behind. Make sure that it gets all in there. And then I'm just going to let that filter for a little bit. And then I can kind of read to make sure. So it says wet the filter paper. I did that. And it says it should be a blue filtrate. Filtrate is a vocab word for something that comes through the filter paper. And so if I take a look at it, oh yeah, certainly I am getting something blue. That's a good sign. That means that I'm getting what I was expecting. So as it separates from the copper wad, through that filter, you're seeing that blue come out. So that's what I was looking for. I wanted a blue color, so that's a good sign. So I'm gonna let that finish. While that is finishing, so my observations would be that the copper goes back to kind of that brownish red color. The blue liquid or the blue filtrate comes through the funnel into my Erlenmeyer flask. That's what you would write down for observations. While that finishes filtering, I'm gonna get part 1C set up. So let's see what it says. Slowly add 10 milliliters of 6 capital M's. There's that molarity measurement again, which is a concentration of sodium hydroxide. I'm going to use that same graduated cylinder, so I'm going to rinse that out really quick. It is safe to go down the sink because the small amount of acid that was in there is not going to damage anything in our sink. And then I'm going to do that same thing, that safety piece. I've got this secondary container for the sodium hydroxide, and then I've got my beaker with my pipette in there. And then this one again says 10 milliliters. So I'm going to just use my pipette to get that in there. And it says that I might have to use more than 10 milliliters. I'm going to start by measuring out the 10, and then I'll measure more if needed. Again, being kind of cautious. All right, so then now I've got my 10 milliliters of sodium hydroxide, and it says I'm going to add that to the filtrate, which remember is the blue part, and not pour it through the funnel because otherwise all of my stuff will get stuck in the funnel, and I need the stuff in the Erlenmeyer flask. It tells me that I should see a precipitate, and that precipitate is going to be the copper compound. So that's going to help you when you're writing your balanced equations and figuring out states of matter. The one that is solid, the precipitate, will be the copper compound. And it says note the color immediately. All right, so we're going to give this just a little bit more time to finish filtering. Okay, so this looks like it's pretty much done filtering. You see that blue filtrate at the bottom. I'm just going to take the funnel out for now and just set that in my test tube rack so it's out of the way. And then remember, so we just finished 1B, where you made sure you observed this as your for your observations, and then now we're on 1C. So slowly add the 6 molarity, 10 milliliters of the sodium hydroxide. So take a look at the solution. Right when I add it, what do you notice? Okay, record that color right away. So that brilliant blue, and then look how it's like chunky, definitely a precipitate. And then remember that precipitate is my copper compound. So when you're writing the equation, that's what you're looking for. All right. So I have my new color. I have my new observations. Step 1C was really fast. I'm ready for part 1D. It says transfer 20 drops of that mixture you just made. So I'm going to use a pipette to transfer 20 drops of that into a medium-sized test tube. So here's my medium-sized test tube. So I'm going to try to get some of that stuff I was just looking at. So making about 20 drops. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20. Okay. So I got some of that precipitate down at the bottom of my test tube. And then it says to add 3 capital M of that sulfuric acid again, drop by drop, and while gently shaking the test tube. All right, so here's my sulfuric acid. I actually did want to show you this to you before. So the sulfuric acid formula is H2SO4. So remember, those acid formulas are a little bit different for writing the formulas. So I wanted to give you that one. So sulfuric acid. So I'm going to add a few drops of this. So I'm starting with my dark precipitate, and then I'm going to add a few drops of my sulfuric acid, and then kind of mix it together, and then add maybe a few more drops, mix it together. Look what's happening there. All right, maybe one more. All right, so then now you can see it's definitely that precipitate is gone. It's clear now. There's a little bit of a yellowish tint as the reaction happened. And then if you were here, you would see that it's warm. Maybe you can see there's some steam on that test tube. That's also showing you that there's some heat that has been released. So it's warm and it goes back to all the precipitate disappears and it's kind of a clearish yellow, but definitely a solution now. You can't see any chunks and it got warm. All right, so there we've got step 1D. We made that precipitate disappear. So when you're writing your compounds, you're going to see something that is all, there's no solids anymore. And then I'm ready for the last step. So last step says using the remaining products from 1C. Okay, so that was this solution that we used. Take a look at how different this looks now. Remember, it was like a brilliant, beautiful blue right away. So it says for this one, gently boil the mixture. So if we would have needed to do this, I would have taken off this clay triangle with the crucible, and instead I would have put a wire screen on that ring, which then would be able to hold that Erlenmeyer flask, and I would have heated it back up. But here's the thing. Sometimes this reaction in step 1D happens on its own just from collecting warmth from the room. So I didn't have to add any heat from the Bunsen burner. So heat was added. It just added it from the room. And then now this is what it looks like instead. It's like grayish, brownish, black precipitate now instead. And so remember in our lab, the first thing we made was kind of a grayish dark color. So it turns out that the first thing we made in step 1A is also the same thing we made in step 1E. Again, it did heat up, so when you're writing your reaction, heat is included. We added heat. It's just that the chemicals added their heat from the heat in the room, and I didn't have to add any more from the Bunsen burner. So that is your last set of observations for 1E. It happened on its own, so we didn't have to add any more heat. But this is now your observations, kind of this dark brownish, gray, black precipitate. All right, so that takes you through types of reactions. So now you're going to write some balanced equations. You're going to classify. Every equation you write should have states of matter with it. And don't forget to balance those equations. And then for classifying reactions, you're looking for combustion, synthesis, double replacement, single replacement, or decomposition. Thanks so much for being my lab partner today. I'm going to get all this cleaned up while you work on your lab report. Bye.